So, hello guys, my name is Amrit Sundaka. I am a student pursuing integrated MTech in software engineering in VIT Vellore and also a core member of IEEE Computer Society. Today, I am going to enlighten you about the concepts of DBMS. DBMS in the sense of database management system. Where do we use this? In airplane reservation system, railway reservation system, in our colleges, in our phones when we text someone, everything is stored in a database. Everything whenever like you in the future will go to try to make apps and websites, you will come across a problem that this data is stored statically in my phone only, but I wanted to send it to someone to other phone over the internet. How will I do that? You have to first store it in a database. That's why the importance of DBMS arises. So, thus, today I'm going to introduce you to the basic concepts of DBMS and explain the theory behind it, and also going to do some structured query language, which is a programming language, which will help you to visualize it, what we are learning today. So, let's see what we are going to cover in this session. We are first going to say what is data and what is database and why do we use database. Why not the old file management system which we were using before the discovery of DBMS? What are the different levels in DBMS? How do you design a database? And the most fun part, I think, of the session, which is querying in SQL, which we are going to code in SQL programming language. And when we code something which we have an idea of, it looks like it feels better. Like we have an idea and you visualize it on the computer screen. So it's like that. So let's get started with the introduction. What is data? Data are the known facts which can be described in the real world. It's like marks obtained by a student, number of students in a class, age group of a student, salaries of an employee. Every known fact in the real world which can be recorded and have some meaning in their value are known as data. A collection of related data is known as database. So now, for example, you can say in a student table, what will you have? Like if you have to detail records of a student, what will you have? You will have his name, his roll number, his gender, his age, date of birth, attendance, marks obtained. So these are all like closely related, right? A collection of like this type of related data is a database. And the software or like the apps which we use to implement this is known as the database management system. Some examples are Oracle, MongoDB, and many others. So now let's get to the part that why do we use DBMS? Why not file system? So now imagine like you're storing like millions of employees of data. Like there are millions of employees, there are millions of customers, millions of products, and you're maintaining all of the data in a Word file or in an Excel sheet or like heck even like in Notepad, like in only just text. Like there's no link between them. There is no way to like find them in a faster. You know how much the storage it will take? It will take some terabytes or like even petabytes of storage, and we don't have that much main memory. Also, the computers like we have developed and which we work in generally are either 32-bit or 64-bit computer system. They cannot operate more than like some 4 GB of data at a particular time. So like when we try to access, they can only access like some part of the data. And suppose the data is at the total end of the file, it will take we have to like analyze all the data to get to the part. And that's not like fast or efficient. Also, there is no way to link to tables. Like also, like you can think of a scenario like there is an employee who is working in sales department and also working in the managing department, and he had to change his phone number. Now you have to make this entry change in both the places. Also, like changing multiple places lead to data redundancy. That means you will have to have there might be a chance of an error while copying or pasting, like since we are doing it at multiple places. Also, it doesn't save us from the inconsistent changes. Suppose two users are trying to change the same piece of data at the same time. It might cause the file to crash and the whole data to be lost. And data stored in the file systems have like very minimal chance of to getting restored. That's why we use DBMS. DBMS solves most of the problems. It provides an abstract view of the data. We are going to look forward like what an abstract view means when I cover abstraction in DBMS in the next section. For now, you can think of it like it's a black box. Like all the complexities and like complex details are hidden, and the stuff which the user wants is shown on the screen. There is no unusual stuff on the screen. It also gives us sophisticated techniques to store and retrieve data. Like it has transaction control language. Like the previous issue which we had, like if two users or like multiple users are trying to access the data, it might lead to file crash. But DBMS has some transaction control. It uses some asset properties, which is accessibility, secure, informed, and data safe, like something like that. So with this, it controls multiple users and it doesn't lead to data loss. It also protects the users from system failure because it has commit and rollback features. Like if by some error database crashes, we can still have the data of the last commit and the data is not lost totally. The apps made from DBMS are robust and standalone. Since DBMS uses a standardized protocol, it is not the apps are very easy to make because they are following the same rule. Now let's move on to the next part, which is abstraction in DBMS. So the DBMS, you can think of it as divided into four levels. One is the database, which you can see here. Here we store all of our data. And there is three levels. There is a physical level, or we call it the internal schema, a conceptual level, and an external view. Let's go into one of them one by one. So, physical schema tells us where the data is stored. Like, is it in C drive, D drive, under which folder our database is created. It also stores the system catalog. Now, you might ask, what a system catalog is. So, in your database, whatever tables or like relations you're using, it has a basic overview of it. Like when you go to a restaurant and you ask the waiter, show me the menu gives you a details that what food items the restaurant has and what are the prices. If you go to a mall or a shopping bazaar and you ask for a catalog, it just gives you the overview of the products available there. It is here no different. Suppose we have a table which have student, course, section, grade report, and prerequisite tables. They have it stores how many number of columns it has. It also stores what are the columns and the data type, like name, which can be a string or a character of 30 length, a student number, class in the student table, in course table we have course name. So like it gives us the overview of the database which we are currently in. So now let's go back to the diagram. Now that we have understood what is physical schema, we need to understand what is the conceptual schema. So, conceptual schema isn't about like how like where the data is stored or what is the overview. It is actually about the data stored. So, now we are talking about in details about the data. Like in course, we have intro to computer science, data structures, discrete database course, which have this many credit hours and are from this department. It tells us what are the data stored in each table, and it also stores the relationships between the tables. Yes, in database, you can also link two or more tables using foreign keys. What is a foreign key? We will discuss in the next sections. But for now, you can think of this example, like you can see here. Now, what if I want to know that the intro to computer science is for taught by which instructor? There are two different tables, right? So we can link them using a common attribute, which is the course number. So it will search intro to computer science. It will take this as the foreign key and it will search it here. Here we have two instruction, Anderson and the same Anderson here, but you got the idea, right? When there are two attributes of the same type, they can be linked together. So now let's move on to the external view. So in the external schema, it tells about the application about the how the data should be shown. So now we are coming here. It's the what we see out of the black box. So suppose a user comes and he doesn't know a lot about like programming and all like how is it related. He just wants to know what are the courses which have 4 credits. He would write a query about that, like show me all the courses which have 4 credits, and it will only show him that. These are the courses which have 4 credits. It doesn't show like how many columns it has, what are the other columns, what are the other rows, or what are the tables it has been linked to. It doesn't care about that. It only cares about what the user asks and show him the output. It hides all the complexity. We can also write some complex queries like show me all the courses which are from the fifth year students, and it falls under fall semester. So this is the schema. So to be sure, let me like summarize it for you once again. So database is the place where our data is stored. In physical level tells us where the data is stored, and it also maintains the system catalog, which is an overview of our database. Conceptual level, it actually stores what is the data, and it also stores the relationships between two or more tables. This view, external view, is the view which we, you, and everyone who uses a database see, like the input and the output. So now that we have covered about the abstraction in DBMS, let's move on to the next part, database design. Now imagine a scenario where like you have been a certified database designer, and a client from like a university comes up to you and says, "Hey, I want to make a department table and a student table, a course table, a faculty table, and an all the employees table." So he will tell you all the requirements he has, but how will you show him like what are you going to do? So to visualize it, we use the ER model or entity relationship model. Relationship, now that this word has been used very often, you know it is used to relate two or more tables. An entity, let me describe what an entity is. An entity is the name of the relation, like the name of the table which we are dealing with. Like students table will student, course, like that is an entity. Why are we use this ER model? Because it's a widely used concept model and it's very easy to understand. Don't believe me? Let me show you the next slide, which has an example of how simple the ER model is. So the ER model has like, in this example, we have 3 tables. One is department, one is project, and one is employee. So these are the name of the tables we have. And what you can see these names in this bubbles, these are the attributes or the columns in our tables. So one minute. So now you might be wondering, why is there an underline here? Why is this double ellipse? This has some special meanings, which I'm going to show you. So this is what are the symbols and what they signify. So a rectangle means an entity, which we already discussed is the table name. Now, what is a weak entity, which is like denoted by double rectangle? Now, so think in the scenario of a school. In a school, we have students, right? And students also have parents. So if you write a table with students and you make a table parents, how will you to, what is the relationship between them, between a student and a parent? The student is a children of parent. Now think, suppose student table is not there in the school and there is only parents table and the relationship is children of. Does it make any sense? If there is no student, then what is the meaning of having a parent, right? So entities which cannot exist without the relationship, without being in a relationship with a strong entity are known as weak entity. They always need to depend upon a strong entity, otherwise they can't exist. And the relationship, to identify them, we also use double rhombus, or you can say the square, which is flip 45 degrees double. Attributes, as I discussed, is the column names like name, number, address. A key attribute. A key attribute denotes that this attribute can uniquely identify each row of the table. We will go more about what are the keys like primary key, candidate key, foreign keys later in the section. A multi-valued attribute. It's to denote that this column for one user might have multiple values, like a user might have multiple email address, multiple phone numbers, like that. A composite attribute, when an attribute can be divided into further parts, like address. Now, an address can have a flat number, floor, street number. state, city, it can be divided into further parts. That's why it's a composite attribute. And derived attribute is denoted by dotted ellipse. To give an example, it is like derived from another attribute. Like you can derive someone's age from their date of birth. So date of birth is a normal attribute and age is a derived attribute. Now let's go on to relational model, and after that we will go for SQL. Now you have to pay extra attention here because this is the thing which is more important if you want to do SQL. Without understanding of this relational model, we can't write SQL codes. So what is a relation? Right now I have been telling the relation as table. Table is an informal word, and in the world of DBMS, informally we call it a relation. A relation looks like a table of values. It has a set of rows which are the data we stored, and data in each column has a indication. Like suppose there is age, and age will always be a number. So under the age column, whatever the numbers are, you get that it's the age of the specific row. To explain it more clearly, here is an example. So you can see we have a table with the table named student. From now on, to be like more familiar, now I'm going to call it relation because it's the form of verb. So we have a relation here and the relation name is student. So now generally we will call all of these like a name, SSN, home phone as columns, but formally they are called attributes. And we will call all of these individual data as rows, but formally we call them tuples. So what you might be thinking, why I have written degree and cardinality here, like degree 7, cardinality 5. If you look further into it, you will like simply understand degree is the number of attributes we have in a relationship, which tells us how many attributes we have, and cardinality tells us how many rows of data we have in our table. So this is again the same thing, what we call like normally or informal, and what we call them in the language of DBMS, like table relation, column header attributes, all possible values domain, row tuple, like that. So now we come to a very important part of DBMS, which is key constraints. DBMS allow us to enforce certain constraints. Like now you go to a class of 50 students, and there might be someone with the same name, like Akhil. There can be a same name of Akhil, and he might also have same last name. Then how will you differentiate between them? In a class, every student will have a roll number which uniquely identifies each student. And that's very important also in the concept of DBMS. In DBMS, when we have to be very particular in which value you have to get, we also have to detect the perfect row which we need. To that, we always need an attribute or a set of attributes which can uniquely define a relation, like ID, phone number. Like a person given an ID, like an employee ID, a student ID, these are given just to uniquely identify you, so they can be duplicated or they can be replicated. Um, Also, they have to be unique and atomic. What does like atomic attribute mean? It means they can't be further divided like address. Like address can be divided for the further like lane, street number, floor. But these attributes, which are chosen as candidate keys, should not be further divided. They should be the most simple or the most smallest part, like an atom, and they should not be a null value. Like yeah. So a primary key is chosen from a candidate keys. So candidate key as you can think of candidate key as a set of keys or like set of attributes which can uniquely identify a relation, and primary key is chosen, one primary key is chosen out of that. Sometimes it might happen like there is no column which uniquely identifies the whole relation. So you can make a set of two or more columns so that it can be uniquely identified. There is also a foreign key which is used to link two tables to connect a relationship between two tables. So it might be very hard to understand in theory. So that's why I'm going taking you to a table. So there are two tables or relations with the name enrolled and students. So can you tell me like what are the attributes which uniquely identify the enrolled and the student section? So we can see like grade can be the attribute because there is a repetition. We also cannot in the student section we cannot give the name because as I told like see here two names are repeated. We can consider login also, like because the Gmail doesn't allow, or like any mail service doesn't allow you to have the same name if there exists already one. So it can also be considered as a candidate key. Age, obviously, like many people will have like same age, so GP also can be same, so we can't consider that. So SID, login, and here CID and SID can be considered as candidate keys. So now we can see these two tables have one attribute in common, SID. So knowing that, we can make S here in the enrolled, which is the referencing relationship. Here we can make CID as the primary key and SID as the foreign key. Now remember, when you're connecting a table A to a table B, the foreign key of table A must be the primary key of table B. Otherwise, it won't work and you will get an error. So now for an example, I want to know the age and GPA of whoever has the CID Kinetic 101. So it will go to Kinetic 101 53831. It will look into this table for that data and it will fetch the age and GPA. In this way, we can connect multiple tables, not even two. Like we can collect multiple tables using foreign key. So now let's go to the most fun part in the session, which is also, if you want, you can start coding along with me to like have a better visualization of what we are talking. Till now, we were all talking about theory and all. Now we are going to more practical stuff. So structured query language has SQL, which is structured query language, and it has mainly four parts: data definition (DDL), data manipulation, a data control language, and a transaction control language. But in this session, we are mainly focusing on DDL and DML. So DDL stands for data definition language. So it has all the keywords which you need to create a table, to alter the properties of the table, and to drop the table or to delete the table entirely from the database. And data manipulation language, as the name suggests, it manipulates the data inside the table, like to insert the values, to update the values, like that. So the main thing which we are going to cover in this session are create, drop, and alter commands in DDL, insert, update, and delete command from the DML. Before going to that, for creating a table, for assigning columns some values, we first need to restrict them to a domain or to a data type. Like imagine someone coming and giving their age as like 19 in verse. You can't accept that, right? You want the age to be a number so it can be easily understood. You want your email ID to be an email ID. You want your date to be of a data type of date. So it also like helps you to understand and relate them better, because you can't compare a string 19 with a number 17, right? It will not make sense. That's why you need to restrict them to a domain or to a data type. So what are the data types we use in DBMS? So these are Boolean, a true, false, or a null. A numeric value, it can be an integer or it can be a decimal, float, decimal, integer. To store names and email address, we use string. It can be a fixed length, like you have to write char and then the length of the string. Now, suppose you give char 10 and you fill four values like A, B, C, D, and you leave the rest six places. So it will fill up these places with blank. You can also use varchar, which is like variable character with the maximum length. Like varchar n is like you can have any much. It will not fill up the empty spaces with the blank, and it will just leave it like that. But you have to like give a max limit like 20, 30, or someone will just like have a name of length like 2000, 3000 getters if you don't put a max limit. There are also two more data types, which is date and timestamp. Date stores the data of the date, like in the format of YYYMMDD, or you can also use to manipulate it using the toDate function to different types, however you like. Timestamp includes both the date or time you want to insert in the database. So before going to you, now you might ask, where can I run this commands? So for that, 1 minute, let me share my whole screen for that. So you have to go to this site, oracle.com database technologies, and or you can simply type Oracle database XC downloads. It will show you all the data which you need to download. It will be around 2 to 3 GB. After install, just follow the simple instructions. It will ask you for entering a password for a database. Now keep that password very safely, because if you lose the password, it's very hard to reset it. And after you have downloaded it, you just have to press Windows R and open your command window or terminal. Here you have to write SQL plus, and in the username for everyone it's same, it's system, and then you have to enter the password which you gave while installing the software. It's very important to remember the password, because if you forget it, it will be very hard to retrieve it. So when you type the password, it will not be visible, but it's getting typed in the command prompt. And when you press enter, see, you are connected to the database with the latest edition and all that. So here we can create our tables and we can view them as we want. So let's get back to our PPT and see. Wait, let me change to the slide we are in. So first, to create a table, we need to learn the syntax. Now notice whatever I have written inside this greater than less than symbol, these are variable, and variable can have any name. You can give it any name you want, but it's always good to have meaningful names when you have to give table name and attribute name. Data type, as we discussed like previously, it can give number, varchar, date, timestamp, whatever. And constraint is like the, as I told, like you can keep it not null, you can keep is that primary key, foreign key. These are the constraints you're talking about. You can have any number separated by commas, and then you have to close the round bracket and then end it with a semicolon. Semicolon is the terminator, and it tells SQL that you have ended your line. So let's create a very simple table in our database. Press at create table. Let's create students table. Students. Now I give a brace and I put enter. We will have a name, and it would have a variable varchar2 of max length 20. And this is our first column. We are ending it with a comma. We put enter. Now we put a roll number, and it should be a number of length 3, like 12999. And we want the roll number to be a primary key. So let's write primary key. The syntax is like that. If you want to make a column your primary key, you just write primary key and then roll number. Now I have completed making my table. I will just end it. This curly bracket is the closing of this. And since we have ended our line, we will give a semicolon. As you can see, the table is created. Now, to view the properties of your table, you can use a describe keyword, which is used as DESC and then the table name, semicolon, and C. We have the column names name and null. You can notice since I have not given it the constraint of not null, it's not showing here. And it has the data type varchar2, which is a string type, and we have roll number. Now see, even though we have not given not null constraint, we can still see not null here. Do you know why? Because we gave primary key. A primary key must be unique and not null, so it automatically came here, and we can see a data type as number of length 3. So let's get back to the PPT. Now we can see to the next part. This is an example of a creation of a big table. Like I told, first name varchar and a constraint not null, last name should not be null, SSN, and then like all the details with the date, decimal, and the primary key, which we are making SSN because it's a social security number and it's like unique for everyone. That's why. Now, suppose you see, you think like, now I don't need this table. I need to delete it entirely from database. So you use the command drop table name. Don't be confused. Sometimes people forget that they also have to write table before the table name. So now I will just drop the table which I just created. Drop table students, which is my table name. and you can see table dropped. Now, if you try to describe students, see the student doesn't exist. That's why when you drop the table, it's entirely deleted from the database, and you should be very careful while doing so and should copy its data if it's necessary or going to be used in the future. Thus, another DDL command is alter. Alt now alter is used when you want to modify the properties of a table. Like you thought of adding an age to the students table. You thought of dropping the name column. You thought of modifying the type of the ID to a string. So we are going to do all that now. So let's create our table again. Create table students. Oh, I forgot to mention one more important thing. SQL or this SQL Plus is a not a case sensitive language. So even if you write in capital or small, uppercase, lowercase, it doesn't matter. We write name, give it varchar 2 of length 30. We give it roll number of type number 3, and we make roll number the primary key. Again, it doesn't matter what case you are. I'm just writing because it looks good. And yeah, the table is created. Let's describe it. Perfect. Now I want to add age column in the students table. So let's see what's the syntax is. The syntax is alter table, table name, and add the column. So we're just gonna do that. Alter table, table name, which is students, add column name. So column name is age, and its type is number 2. Like in age can vary from 1 to 99, and that's it. Table is altered. Now if you write DES to students, we can see that age is added as a column. So now let's see the next command, like drop column. So now I want to drop name. Alter table, table name, which is students, drop column. Let's drop name, yeah. And now the table is altered. Now when you describe it, the name is gone. Now since I want name for future purpose, I will just add it back again. Alter table students, add name varchar 2 of length 20, and yeah, now we describe it. Sweet, we got the name, but it's in the last. That's fine, I think. We can also modify the type. So I think now no, I don't want my age to be a number. I want it to be like a varchar. So you can just do alter table students, modify a column name directly, which is age, and the new data type which you want, which is in this case is varchar 2 of length 10. Now it's altered, and when you describe the table, sorry, yeah. Now you can see the data type is changed from number to varchar 2. So that's all about the DDL commands. Now we move on to DML commands, or the data manipulation language. So to first view the data, we first have to insert it. So let's insert some data in our table. The syntax is insert into table name, and you can also additionally have column names, but I have not written it. Values, then the column names. So let's write them. Insert into table name, which is students, values, and now the data. Like first we have roll number. So roll number is of type 3, so we will give 1. We'll give it a name, and you should enclose this varchar in single quotes. So we can give a name. Okay, first we have age. Okay, so I'll read the age as 19. and we can write a name, and the row is created. Let's insert some more values. Insert into in command line. You can also use the up key to update, like to get the previous line. So we get 2. We change this to 18, and just change this to um. Okay, I made an error. Again, let's change to in some data, and should be good to go. Now, one thing I want you to notice. Now, suppose purposefully I change some here, like I purposefully try to like enter the 3, which is our primary key again here. So let's see what happens. See, it's giving me an error that unique constraint is violated. Our when we made the table, we told like roll number is the primary key and it should not be repeated at any point of time in our table. So when we try to insert it in our table, we get the error. So now that we have some values in our table, we would obviously want to see how it would look. So the syntax for here is select the column names which you want from table name or names when you're using multiple tables, and a condition or order by if you need to. I will go to them one by one. So first let's see our table. Select. Now when you want all of the columns to show, you can just simply use a star and it will just show all of the data in your students table. Like you can see, whatever I entered is being stored here. So now suppose I want um, the data. Now I can some put some conditions to like make my data more accurate to what I need. So like I want all the students details whose age is 18. So to do that, we can just do select star from students where after where you have to write a condition where age is equal to, here you have to always use single quotes since it's a string, and see it extracted the 19 which was not similar and printed us the matching results. There is one more command which is update. Now at one point in time you will be like, okay, I want to update the phone number, I want to update the email address. So for that we have the update command. So let's try one. Update table, table name, which is students, set set like let's write set age equal to 11, where our roll number is equal to 2. um Let me check. Okay, we don't write table here, my bad. We when we are doing update we don't need to write here table, so this was the mistake. Okay, I'll just correct it. Update students at age equal to 11, where roll number equal to 2. Now I did it. Now if you do select star from students, again the mistake. Here you can see the age is changed here. We have updated the value. We can also delete the values like writing delete. Uh, Now in case of delete, you don't need to write the column name. You just because we are not deleting a column. This is data manipulation language. We are deleting the data. So you have to write delete from table name where Let's write roll number equals to 1. Now you can see the one row is deleted. You're gonna select star from students, and you can see our data is deleted. Now, if you write delete from students directly without giving any condition, it will just delete all the rows in the table. Remember, this is not as same as delete dropping the table. Dropping the tables means deleting it entirely from the database. But if you delete from a table, you can still insert into the table. Like if I try inserting into a table, insert into students values 1 comma age is 11 and some name. See, we can still insert it and the table is still present in our database. So there's a wide difference between dropping a table and deleting a table. Now, suppose you don't have the database working, you have some issues, you can also rely on this program is online SQL compiler. It will have some issues with the describing the table, but it works excellently as you can see for the DML commands. Now, to show you some more examples, what we can select, I'm going to use this. So let's delete all this stuff. And the structure is also given on the left side. You can also create your own table here, like create table students, like I did, and write a name with varchar2 15 and an ID, which is a number of length 3, and we are making ID as the primary key. So primary key ID, and we are closing the table, and we do run SQL. SQL is successfully queried, and you can see we have a students table with name and ID here. The problem with this is that when you try to describe it, it doesn't work. Like if you describe students, see, it says an error, it's a syntax error. It's not a syntax error, it's just that this compiler cannot handle. But you can almost do anything. Now, I'm going to show you some more examples of like SQL here. Um, let's see. Now, I want all the data to be presented in the form of first name in the descending order. So what I can do is select star from the table customers, order by. Using order by, you have to then mention the column name, like first name in this case, and then ASC, which is the default. You don't need to write ASC if you want it in ascending order. It's by default that it does that. But if you want in descending, you have to use DESC. So this is a very good question, which many times it asked. What are the two uses of DESC? It can be used to describe table in DDL, but it can also be used to represent the descending order in order by. And when you run it, you can see it's B, D, J, J, R in the descending order. You can also give multiple attributes like now you want the first name to be in descending order, but you want the age to be in ascending order. So like suppose John, John, these are two repeated values, right? But their age also are in descending order. You want them to be in ascending, so you can just give a comma, write age, and then write ASC. Again, there is no need to write ascending, but it's easily use. It's like very user friendly to write it, and whoever reads your code will like, no, yeah, you know this thing. So when you do this now, you can see now the this doesn't change. This is like the same way, but when we have the same data, John, John, we have them in the ascending order of their age. And this way, you can just give comma and add multiple values of however you want it. You can also write some conditions like I want my data so that it would have at least a B in it. Like it should have a B in the start or end or middle. Like the first name or the last name should have that. So to put such conditions, we have to first use where, which is the syntax for our condition. Then we will give a brace and we will write where first name live, and then in single quotes we'll describe. Now there are two ways of describing. Now percentage. In percentage b percentage, if I write, it means anything before b and anything after b works. But in the same way, if I do dash b percent, So that means before B, there can be anything, but it can be only one. It can be either A, B, 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 C, B, anything, but only once. It can't be like A, B. And percentage, as I told. So if you are considering this string as an example, it is like you can say it like it can have anything after B, but B must be the second alphabet of the word. But we are searching like B can be anywhere in the first name. So we are doing this percentage V percentage, and we are closing the bracket here and putting an or like either this or last name. It can also have a B in the last name. So let's run this query. You can see B here. David doesn't have the B, but Robinson in the last name has a B. Here Betty, even though before it has nothing, but it has after it. And this percentage can take no or all. So it works like that. Um, Now let's see some more examples. Let me see. We can also, using this, we can also show you. Now think orders as your main table, and you want the order ID in 134 to show the customer ID of that because they are linked here, right? So we are going to link two tables now. So this is where starts getting complicated, but if you go along with me, it would be easy. So let's start. Select. Now, since we are using two table, it's not recommended to use star. Now you have to name each column, and if there is a same column like here customer ID, you have to give an alias. Now let me write. Give me the order ID and the amount, the first name and the age from orders, uh, orders, customers. Now I'm using more table names in the from condition, like not condition, from statement, where now you have to link these two. What's the common link between them? The customer ID. So you have to write like orders dot customer ID is equal to customers dot customer ID. So now you run it and you can see like order ID 1 has customer ID 4. So it shows the details of John Remudot. You can see John age 25, like this. You can easily link table. Now, with more tables in hand and like longer name of the table, like writing this is kind of an hassle, right? Then give them aliases. To give them alias, you can just write orders, then a space, and then write O to represent it. And for customers, we can give a space and C. And now we can just write O dot customer ID, C dot customer ID, and see we have the same result. Aliases just make our work a lot more easier. And with this, you can still give your conditions like where order order ID in. Within, you can use a tuple of values like customer ID in 1, 3, 5. Now, if you write like equal to condition for all, you have to write order ID is equal to 1 or equal to 3 or equal to 5. That's like a lot of big deal. So you can just use in and mention the values you want to check. Or you can also use another keyword between 2 and 4. It is inclusive, like it will include 2, 4, and whatever is in between them. So if you run it now, okay, it shows an error. Mm, I don't know why. Should not. Getting errors is just a part of a learning. So, oh, okay. Now I see. So this is a mistake. I got it. I have used where here, and I'm again using it here. So that's not the right way. You should use and in this case. So you should put it in braces, and you should also. So it's like better to see and understand now. So now if I put this. See, we got 135, and in between, now if I try 2 and 4, sweet, we got 2, 3, 4. So this is how you can write queries, like complex queries between multiple tables, joining them, connecting them, writing the values you want, ascending, like ordering them in the ascending order, descending order, like that. So database allows a lot of stuff. And that's all from me. Thanks for patient hearing. And I hope when you have listened to me patiently, you can now have some basic knowledge of DBMS. And when you go like making some website and app, you will have an idea that what you have to do, and you won't be like blindsided, like what I have to do, I don't know. So I hope I was able to help you in that. So that's all. Thanks for. I'm Amrit Sundarka, core member of IEEE VIT Vellore.